Look out at the vast Atlantic Ocean. It is an immense body of water. It separates continents. It shapes our world. Now, imagine something extraordinary. Picture a pathway stretching across its surface, not for ships, not for planes, but for us, for people walking. This is the transatlantic footbridge, a bold vision, a project to connect London with New York City, two iconic cities, two continents linked by a thread of human ingenuity. It seems like science fiction, yet it is a dream we are beginning to explore. The scale is almost too large to grasp. 5,000 kilometers, that is the distance this footbridge would span. Think about walking that far, across restless seas, underneath vast skies. It is a journey of incredible length. This project pushes the very limits of what we believe is possible. It challenges our understanding of engineering. It tests our capacity for grand undertakings. The ambition is breathtaking. It truly reaches for the stars, or in this case, across the ocean. This is more than just construction. It is about conquering a frontier. Why would we undertake such a colossal task? What drives us to connect landmasses in this way? It is the human desire for connection, to bridge divides, to foster understanding. A footbridge offers a unique perspective. It allows for a slow, deliberate journey, a chance to contemplate the vastness of our planet. It is a fundamentally human scale of travel. This project is not just about A to B, it is about the experience between. It's about uniting peoples and cultures in a new, profound way. The very idea of a transatlantic footbridge is audacious. It speaks to our inherent curiosity, our need to explore, our drive to build wonders. Some might ask if it is even feasible. The challenges are undoubtedly monumental. Many would say it is impossible, but humanity has always been drawn to the impossible. We look at great voids and dream of crossing them. This footbridge is a testament to that spirit. It is a statement of hope, a symbol of what we can achieve when we dare to dream big. Such a monumental vision requires immense resources. The estimated cost is staggering. 25 billion euros. This is a figure that demands careful consideration. It represents a significant investment. It is not just money. It is resources, materials, and human effort on a vast scale. This kind of expenditure reflects the project's ambition. It underscores the belief in its potential value. A project of this magnitude requires serious financial backing. It needs nations to come together. This sum highlights the scale of the engineering challenge ahead. The funding for this grand endeavor comes from Europe. This is a significant commitment. It shows a collective will to achieve something remarkable. When nations pool their resources, incredible things can happen. This European backing signifies more than just financial support. It is a vote of confidence in the project's feasibility. It is a statement about the future, a future where bold engineering projects can unite us. It also means the project carries the hopes and expectations of many. This support is the bedrock upon which the dream is built. The immense task of designing this structure falls to skilled minds. Engineers at SPE projects and manufacturing are at the forefront. They are the ones grappling with the practicalities. How do you build a 5,000-kilometer bridge across an ocean? Their expertise is crucial. They must translate this grand vision into a workable plan. This involves countless calculations. It requires innovative thinking. They must consider every single detail, from the largest support pillar to the smallest handrail. Their work is foundational to the entire project. Where does one even begin such a design process? The engineers face unprecedented challenges. The ocean is a dynamic, powerful environment. There are no existing blueprints for such a structure. They must develop new methods. They need to push the boundaries of current engineering knowledge. Initial studies will focus on feasibility. They will explore different structural concepts. They will analyze the forces the bridge must withstand. The ocean's depth, currents, and weather patterns are all critical factors. This initial phase is about asking the right questions. The very structure of the transatlantic footbridge is a marvel in itself. Imagine its spine. It will be composed of around 200,000 concrete sections. This number alone is difficult to comprehend. Each section is not a simple mass-produced block. Far from it. Each one must be individually designed. Each one must be meticulously studied. Think of them as custom-made vertebrae in a colossal skeleton. This level of detail is essential for the bridge's integrity. It is a puzzle of epic proportions, with each piece vital. Why this need for such individual attention to each section? The Atlantic Ocean is not a uniform environment. The seabed varies dramatically in depth and composition. Ocean currents exert different forces at different locations. Water temperature and salinity change along the route. Each concrete segment will experience unique stresses. It will face specific environmental conditions. Therefore, each must be tailored. Its design must account for its precise place in the overall structure. This ensures strength and longevity across the entire 5,000-kilometer span. The task of designing and studying 200,000 unique sections is monumental. It requires immense computational power. Vast amounts of data must be collected and analyzed. Oceanographic surveys will map the route in minute detail. Sophisticated computer models will simulate the forces at play. Engineers will pore over these results. They will refine each design. Precision is paramount. There is no room for error when building on this scale. This process represents a significant engineering feat in its own right, even before construction begins. This also poses a challenge for materials science. The concrete used must be extraordinary. It needs to withstand the harsh marine environment for decades, perhaps centuries. It must resist saltwater corrosion. It must endure immense pressures at great depths. It needs to be strong, yet potentially flexible enough to handle ocean dynamics. Researchers will be developing new concrete formulations, perhaps incorporating smart materials that can self-monitor or even self-heal. The innovation required for the bridge's very fabric is immense. This is about pushing material limits. Beyond the structural design of the concrete sections, other complexities loom large. The North Atlantic is known for its ferocious weather. The bridge must withstand hurricane-force winds. It must endure colossal waves. In northern sections, it might encounter sea ice or even icebergs. The safety of walkers is paramount. Then there is the marine ecosystem. Construction and the bridge's presence must minimize impact. We must build with respect for the ocean's inhabitants. These are not small considerations. They are fundamental design drivers. Overcoming these challenges will demand constant innovation. We cannot rely solely on existing technologies. New construction methods will be needed. Perhaps autonomous underwater vehicles will play a key role in assembly. Advanced sensor systems will monitor the bridge's condition in real time. They will predict and warn of any potential issues. Power generation along the bridge will be vital. Maybe harnessing wave or wind energy, every aspect of the project, from logistics to maintenance, will require fresh thinking. It is a testbed for future technologies. If successful, the impact of the transatlantic footbridge would be profound. Imagine the cultural exchange. People from all walks of life meeting on this unique pathway. It could foster a new sense of global community. Economically, while not a trade route, it could spur tourism and related industries. Scientifically, the bridge itself could serve as a platform, a 5,000-kilometer-long ocean laboratory, for studying marine biology, oceanography, and climate change. It would be more than a bridge. It would be a destination, a source of endless discovery. Ultimately, the transatlantic footbridge project is a statement. It is a testament to the human spirit of exploration and creation. Like the pyramids or the journey to the moon, it speaks of our desire to achieve the seemingly impossible. It pushes us to innovate. It forces us to collaborate on a global scale. Whether it is fully realized in our lifetime or not, the very act of planning it expands our horizons. It encourages us to dream. It reminds us that even the vastest oceans can, perhaps one day, be bridged by human endeavor.